Hi everyone, welcome to our video on working with a function and finding where we have x values that have a horizontal tangent line. Okay, so in our previous video we had the equation of a tangent line, which is our three-step process here. Here we're still taking some of those ideas to help us with this problem. We just want to break down, so there's really just one main thing. So if it says find the values of x where the tangent line is horizontal, what this means is if you have a horizontal tangent line, that means your slope, your mtan, is 0. Okay, so a horizontal tangent line is always your slope is 0. If they tell you anything about the tangent line, so if they said find the values of x where the tangent line is 10, then you just do mtan equals that number. Okay, the horizontal one is just a special case though. Okay, so mtan equals 0 when it's horizontal. All right, so let's break that down. So while mtan equals 0, this also means, so I'm going to use those double arrows, this also means your f prime of x is 0. So let's box that in too. So that means for this style problem, step 1 is let's go ahead and get the derivative. Okay, so our derivative, we see our equation there. Oh, and I used f prime as generic. It's g, so that's okay. It still works the same way. Okay, so on this, I think we could jump straight to it. So I use blue to show the derivative for now. So we've got g prime of x is, well, this 3 multiplies the 2/3. So I have 2/3 times 3. And then x minus 1 from the power would be 2. And then plus 1/2 times this 2 multiplies the 1/2. And then x minus 1 from the power would be just x. Here we have a linear part, so that would be just minus 15 as its derivative. And then the last term is a constant, so that means that is 0 as its derivative. Okay, so this is the derivative, and then we do our one step to simplify. Okay, so 2, that's too high. Okay, so the 2/3 and 3, the 3's just cancel each other out, and we're left with 2 x squared, and then we have plus 1/2 and 2 cancel out, so we have just x, and then minus 15. Okay, so this is the derivative. I'm just going to cloud it in case they wanted it. We could write it for them. Okay, but our next step to find where the values of x have a tangent line being horizontal, I want to set the derivative equal to 0. So step 2, let's set derivative equal to 0. So that means this portion right here, the derivative is 0. So we've got 0 and then equals the right side. So 2x squared plus x minus 15. And then so now we're going to solve. So set the derivative equal to 0 and solve for x. Okay, so this is a quadratic, so it looks like we should factor to solve. Okay, so my scratch work, I have 2 times negative 15 is negative 30. And then the factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And I'm looking for the pair that adds up to 1. Well, it looks like if I did negative 5 and positive 6, that would do it. And notice these multiply and give us negative 30. Okay, so I've got 0 equals 2x squared. And then I'm going to rewrite this plus x as minus 5x plus 6x minus 15. So our coefficient is 2 for our leading term. So remember, it's not the quickest way to factor. We have to take a little bit more time. Or if you use a different method, that's fine too. Remember to check your answer, though, by foiling at the end. Okay, anyway, so I'm going to do it by grouping, where I group these two and I group these two. Out of the first two, I have an x in common, and then I'm left with 2x minus 5. Out of the second two, I'm going to take a positive. It looks like 3 is in common, which leaves me with 2x minus 5. And then the 2x minus 5 is common in both, so that means I have 0 equals 2x minus 5 times x plus 3. There we go. Okay, and then this is factored. If I distribute 2x squared, positive 6x minus 5x would be positive x, and then minus 5 times a positive 3 would be minus 15. So everything's good. And then now let's proceed once you have one side set equal to 0, we can set each of these equal to 0. And then we could add the 5 and then divide by 2. I'm going to say that that's 5/2. And then on the second one, we could subtract the 3. So there we go. So we found the values of x where the tangent line is horizontal. It's those two. And that's all we got. That's all we needed. Okay, so that's that. So that's a special case. So there's less going on. That's it. We've got it. Okay, so but just to make clear is that if they tell you they want the tangent line to have some value to it, that's where we set the derivative equal to that value. Okay, so that's it. If you do have questions, please let me know. Otherwise, thank you for watching, and I'll see you again soon.